ক্লাস টেস্ট সিটি 1 তো তার নিচে দুটো কলাম করবে CO1 তিনটে CO1 CO2 CO3 ওখানে আর ক্লাস টেস্ট 2 এ CO3 CO4 CO4 CO5 CO6 টোটাল 6টা
স্যার তাহলে সিটি1 সিটি2 দুটো আলাদা ফাইল
হ্যাঁ দুটো আলাদা আলাদা না একই ফাইলের মধ্যে পাশাপাশি থাকবে
ঠিক আছে তাই
হ্যালো তোমরা শুনতে পাচ্ছ হ্যালো 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 can you hear me yes sir okay Well, we will today discuss clauses first. What are clauses? Clauses are well-formed formulas consisting of disjunction of literals. That means this is a special kind of well-formed formulas represented with disjunction of literals. Now, can you tell me what we mean by literal in the context of predicate calculus? Respond, please. What is a literal? This we discussed several times in the past. Please answer. Any of you? Otherwise, it is very difficult to carry on this class. What is a literal? If your mic is not operating, then answer over the chat board. What is a literal? Class করা যায়? So Akanksha, thank you Akanksha. Akanksha has answered. A literal, it may be an atomic formula or its negation. Now, what is an atomic formula? Answer, please. What is an atomic formula in predicate calculus? Predicate cluster, okay. Both of Akanksha and Ratu, they have answered. Predicate cluster constitute an atomic formula. Thank you. Now, what is a well-formed formula? It may be one or more atomic formulas combined with connectives like and or not implication. So these are well-formed formulas. Now clauses are special kind of well-formed formula. What are those? Such well-formed formulas consisting of disjunction of literals. Now, this I shall show later that any well-formed formula of predicate calculus can be converted into clauses. That means, irrespective of its form, any predicate calculus well-formed formula can be converted into clauses. That is, so there is an algorithm which accepts any well-formed formula as its input, and in return it produces a clausal form of that well-formed formula. That is, logically these two are equivalent. That means if you form the truth table for this well-formed formula and this equivalent clause, you will get back the same truth table. They are logically equivalent. So any well-formed formula of predicate calculus can be converted into clauses. Now I have just mentioned this statement. I have not discussed the algorithm for converting a well-formed formula into clauses. That I shall discuss later. But before that, I should explain why clauses are so much important in the context of predicate calculus. Because a special kind of inference rule that is called resolution, which can be applied only on clauses. So resolution is an important rule of inference, and resolution, when found applicable, is applied on a pair of parent clauses to produce a derived clause, also called resolvent. When we started to discuss predicate calculus, I mentioned that one of the major objectives of this artificially designed language is to draw inferences. In abstract form, we want to generate new formulas from the existing one, in a way that these new formulas or new expressions, new well-formed formulas must be logically consistent with the existing well-formed formulas. And for that, we need to apply certain rules of inference of predicate calculus. And previously, I mentioned two rules of inference of predicate calculus. Can you recollect it? Please respond. What are the rules of inference I discussed earlier? What are the rules of inference of predicate calculus we discussed earlier? Please answer. Respond, please. What are the rules of inference of predicate calculus we discussed earlier? Resolution is another kind of rules of inference, and it can be applied on a pair of parent clauses. It cannot be applied on well-formed formulas of any form. Someone has responded. Modus ponens and universal specialization. Oisik has answered. Thank you, Oisik. So modus ponens and universal specialization, this we discussed earlier. Modus ponens can be applied only when the antecedent portion of an implicational formula can be matched with an existing fact or a predicate or a well-formed formula. Then we can apply modus ponens. And universal specialization can be applied if we can have an appropriate substitution for the variables occurring in a well-formed formula. Then we can apply universal specialization. But resolution is, it is another kind of inference rule of predicate calculus which can be applied only on a pair of parent clauses. And once we found resolution is applicable on a pair of parent clauses, we will be able to produce a third clause from those two. And that clause is called a derived clause, or it is also called a resolvent. So we are discussing clauses by putting so much importance on it because afterwards we will learn how to apply resolution to draw inferences from the existing well-formed formulas or from the existing statements or sentences. That is why we are discussing clauses. Clauses are well-formed formulas consisting of disjunction of literals. And since any well-formed formula of predicate calculus can be converted into clausal form, so we can apply resolution on well-formed formulas irrespective of their form. So first we will convert all the existing well-formed formulas representing certain knowledge about certain domain of discourse into clauses, and then we will apply resolution on those clauses to generate inferences or to produce new clauses or to produce resolvents. Now, I shall explain an algorithm to convert a given well-formed formula into an equivalent clausal form. So, I am going to discuss the necessary steps of operations to be followed to convert any well-formed formula into an equivalent set of clauses. So first step is eliminate implication symbols. That means if there is an implication symbol of this form P implies Q, then you have to eliminate this. How we can do this? We can replace this with not P or Q. So this is the first step of operation to be followed to convert a well-formed formula into clausal form. Eliminate implication symbols. If you find any implication symbol in the input well-formed formula, you have to replace it in this form. Then step 2 is reduce scope of negation symbol. Now, the next step is, that is step 2 is reduce scope of negation symbol. Let me explain how we can reduce scope of negation symbol. So this is a negation symbol and this is a well-formed formula for all x px is true. How can we reduce the scope of this negation symbol? We know previously I discussed that it is equivalent to sum x not px. So initially this was the scope of negation symbol. This was the scope of negation symbol, and after we apply this formula, this becomes the scope of negation symbol. So it is reduced. Now in this case, this is a negation symbol. It precedes an existential quantifier for sum x, px is true. And equivalently, it can be written as, by moving this negation symbol in, we can reduce the scope of negation symbol. This will be replaced as this. So this is the way we can reduce the scope of negation symbol in a well-formed formula to convert it into into an equivalent set of clauses. So this is the step 2 of the algorithm. So step 3 is standardized variable. Standardized variable means every quantifier in a well-formed formula should have its own variable. For example, if this be a well-formed formula for all x px implies sum x ux is true. There are two quantifiers. One is universal quantifiers, other is existential quantifiers. And both of these quantifiers have the same variables. And in step 3 of this algorithm, we have to standardize these variables. That means we have to allocate to each quantifier an unique variable. So equivalently, it can be written as for all x1, px1 implies there exists some x2 for which qx2 is true. So this is what we mean by standardizing variables in a well-formed formula. Step 4 is eliminate existential quantifiers. We cannot simply drop existential quantifiers from the well-formed formula. In that case, the logical meaning of the well-formed formula will be changed. We cannot do this. We cannot simply drop it. There are certain rules for eliminating existential quantifiers from well-formed formulas. And I am trying to explain those rules. So I am trying to explain what we mean by eliminating existential quantifier. That means if there is an uniform formula for some x px is true. That means not for all instances of x px is true, but for some instances of x px is true. If constant a be one such instant, then we can replace px with pa. Then we can replace px with pa. This is an example of how we can eliminate existential quantifiers from a well-formed formula. There is another case where we can eliminate existential quantifiers. That is, here the existential quantifier, it has not occurred within the scope of any universal quantifier. But it may so happen that an existentially quantified variable has occurred within the scope of an universally quantified variable. In that case also, we can replace or eliminate existential quantifier. With an example, I shall try to explain it.
আচ্ছা তুই একটা ফ্র্যাকশন পাচ্ছিস
Let us consider this well-formed formula that for all x, there exists some y for which p of x comma y is true. Now in this well-formed formula, there are two variables. One is x and the other is y. X is a universally quantified variable, whereas y is an existentially quantified variable. And this is the scope of scope of from this bracket to this bracket. This is the scope of this universal quantifier. And within this scope, this existentially quantified variable has occurred. That it is the scope of this. In such case, if an existentially quantified variable occurs within the scope of an universal quantifier, then what it means? That for all x, there exists some y. For every value of x, there exists some value of y. That means as if this y is a function of x. So in that case, it can be replaced as So since for all values of x there exists some y, so y can be thought of as a function of x, and let g be that function which maps all values of x into some values of y, and this is called Scolen function. In that case, we can eliminate this existential quantifier and we can replace this existentially quantified variable y with this Scolen function. So this is how we can eliminate existential quantifier from the well-formed formula.
স্যার তবে আমি এটা যেটা আছে না বিশেষ রেলন করে কাজ মানে এটা স্যার
ভুল হচ্ছে
25 বা 50 করে কারণ এটা হচ্ছে 30 এর মধ্যে তাহলে আমি মানে বিশেষ রেলন এই পার্সেন্টেজ
হ্যাঁ নম্বরটা তো 30 এই আছে।
হ্যাঁ নম্বরটা 30 আছে স্যার 75
হ্যাঁ তাহলে দাঁড়াও এটা কি আমি কোনো একটা সংখ্যা যদি এই রেশিওতে ভাগি তাহলে আমাকে তো বাই 50 করে গুণ 25 বাই 50 করে গুণ 15 বাই 50 করে গুণ 10 করতে হবে না এই অনুপাতের নিয়ম। এবার সেটা আমি কাকে বলবো 30 কে বলবো।
হ্যাঁ 30 কে বলবো সেই পার্সেন্টেজ
ওটা পার্সেন্টেজ তো নিচ্ছি না ওটা 30 এর মধ্যেই রাখছি।
হ্যাঁ মানে আপনি
এই যে মাসটা ধরো এই যদি 25 পায় তাহলে 25টা 25:15 into 10 এই রেশিওয়ে ভাগ হয়ে যাবে। এবার এই রেশিওটা কিভাবে ভাগ হবে এটা 25/50 একটা হবে 15/50 একটা হবে 10/50 হবে। এবার এই তিনটে যোগ করো 30 এ ফিরে পাবে।
সেটা তো অবভিয়াস
তাই না?
সেটা তো অবভিয়াস
এটাই তো অনুপাত। এই নম্বরটা পেয়েছি এখন এই উৎপাদন এখন এই পার্সেন্টেজ করবো 30 এর ভেতরে কত তারপরে আমি পার্সেন্টেজ করতে হয়তো পরে হবে। তুমি যেটা করেছো সেটা হচ্ছে যে এটা 100 হলে কি
আচ্ছা
So it is very clear, it is very simple that how to convert the input waveform formula into Prenix normal form just by moving all the existential quantifiers to the front of the waveform formula. We can convert it into Prenix normal form. Now, after moving all these existential quantifiers to the front of the waveform formula, what is left there, it is called matrix. It is called matrix. That means then this is matrix. That is the rest of the part of the waveform formula. So this is for step 5. Next, I shall explain step 6. এটা মুছে দিচ্ছি। মানে যেটা আমরা করতে পারি CO1 এর যেটা পেলো 30 এর মধ্যে CO2 তে CO3 তে এইবার সেটাকে আমি 100 দেব পরে মানে 6টা করে নেব 6টা করে তারপর এভারেজ গুলো ক্যালকুলেট করব 30 এ করে তারপর ওটাকে 100 করব। মানে আগে হলে না বেশি ফ্র্যাকশন হয়ে যায়, ভাগ ভাগ গুলো বেশি হবে না। So in step 6, it states that put the matrix in conjunctive normal form. That is as conjunctions of disjunction of literals. Now I have already explained what we mean by matrix. First we will eliminate implications, then we will eliminate, then we will standardize variables, then we will eliminate existential quantifiers. Then what we will do, we will move all universal quantifiers at the beginning of the well-formed formula, and we will convert it into Prenet's normal form, and other than those universal quantifiers, what is left there is called matrix, and this matrix part is to be converted into conjunctive normal form, that is conjunction of disjunctions of literals. To do this, sometimes we need to apply this formula, that is, if x, y, z be three literals, and if you have a well-formed formula as x or whole of y and z, you can replace this as x or y and x
স্যার তাহলে আমরা
or z. হ্যাঁ, x or z. রেসপন্স হচ্ছে না, পড়ানো কি কঠিন বুঝতে পারছো? So to convert the matrix part in conjunctive normal form, it may be required to apply this formula, that is x or y and z is equivalent to x or y and x or z. Since this AND operator, since this OR operator is distributive, we can replace this in this way. This is about step 6. Thank you.
ব্যাপারটা একই ওইভাবে করা এভাবে করা
আর সকালবেলায় এসে আমি না আমি কোশ্চেনটা করবো এমনি কাটিয়ে
আপনি তো ফটো নিয়ে আসবেন ঠিক আছে
তারপরে তোমার টাইম দেবো, তারপরে ঠিক আছে। থ্যাংক ইউ।
পেপারটা এখানে
হ্যাঁ, পেপারটা না এই সাইডের মধ্যে রেখে দাও, তো হবে তাই উড়ে পুড়ে চলে যাবে, আমার আজকে মাথা ঠিক নেই।
স্যার আমার ফাইলটাও এখানেই
হ্যাঁ,
থাকবে
কোনো অসুবিধা নেই। তুমি ওইগুলো টাইপ করে নিয়েছিলে যেগুলো লিখলাম?
হ্যাঁ হ্যাঁ করেছি পুরোটা ঠিক আছে
ঠিক আছে, এসো।
স্যার চাবিটা
হ্যাঁ, এসো। So in step 7, eliminate universal quantifiers. That means simply drop the universal quantifiers which have been moved at the beginning of the well-formed formula. That is, after converting it into Prince's normal form and converting the matrix in conjunction of disjunction of literals, we can simply drop all the universal quantifiers from the beginning of the well-formed formula, because all the variables remaining in the well-formed formula, they are all universally quantified, because all the existentially quantified variables, if any, in the well-formed formula have already been replaced either by a Scholen function or by a constant. So all the variables remaining in the well-formed formula at step 7 are universally quantified variables. So no need for using those symbols for universal quantifiers at the beginning of the expression, and let us drop all the universal quantifiers from the beginning of the expression. It is in step 7, and in step 8, eliminate and symbols. Because in step 6, the well-formed formula has already been converted into conjunctive normal form. That is, it has been converted into conjunction of disjunction of literals. So, so all the disjunctions in the expressions are conjunctively related. So no need for using separate conjunctive formula there. So drop them. And after that, rename the variable such that each conjunct has a separate set of variables. So this is a conjunct, this is a conjunct. But each set of conjunct has a separate set of variables, and we should drop this and symbol. So what we will get? We will get px1 or qx1. This is as a clause, and another clause. This is clause 1, and clause 2 we will get as rx2 or wx2. They can also be written in this form, that is px1 qx1 rx2 and Wx2, Rx2 and W. So clauses can also be represented in this way. No need for mentioning this disjunction symbol separately because a clause is a disjunction of literals. So, so this is the complete description of the algorithm that can be applied to convert an arbitrary well-formed formula into a set of equivalent clauses. So this is an algorithm. Next, I shall consider an example to further illustrate this algorithm. তোমরা কি বুঝতে পারছো? কেউ তো কোনো কথাই বলছে না। Can you follow this? Someone has answered. Yes, sir. Ratu has answered. All right. Let us consider an example. Let us start with an arbitrary well-formed formula and try to apply the steps of operation for this algorithm to convert that arbitrary well-formed formula into a set of equivalent clauses. So this is a given well-formed formula. We want to apply the algorithm we have just discussed to convert it into an equivalent clausal form. Now, will you be able to do this on your own? This example I have taken from the book Principles of Artificial Intelligence by Nielsen. So I think you will be able to do it on your own. Will you be? Will you? Respond please. Should I do this computation or you will be able to follow it from the textbook? Respond please. I have explained all the steps of the algorithm and this is an exercise. You have to apply the algorithm in a step-by-step manner to convert it into clausal form. Someone is responding. Sir, kindly show the computation. Actually, it is in the book by Nielsen. It is in the book by Nielsen. Can you not follow it from there? Principles of Artificial Intelligence. Okay, sir. So Rahul has answered. So let me close my discussion today. We will have the next class on tomorrow. That is on Tuesday at 6:30. So next class on 11th April. Okay. So I close here. I close my discussion. Thank you. Next day we will have the class.